So moving toward the next slide now. So you can see from here again, just quickly recap it, one entry in the ERP cache prior to pinging a local machine. So that was the initial one, this IP address with this MAC address. You can see that what this MAC address is here on that, and then pinging the 132.196.59 new entry in the ERP table results. You can see here. So if you ping the device, any other device, so it is making the registry in your computer and want to see, okay, who has that IP address with MAC address. So it means that every time when we are pinging any IP address, definitely at that time in our network, that computer also register the MAC address of that system as well. Otherwise, with only having the IP address, make me change after few more computers are adding into the system or mobile phone adding in the system, and you are not sure, like, is it a same computer or a different computer? Okay. And similarly, we can see this thing in Wireshark. If we can see now, notice that the ARP request is a broadcast. Why it's a broadcast?
Because an or every machine has a different MAC address.
Hmm.
The AR sends a message which IP address is
Yes.
attached to which MAC address.
So it's like that. It is just announcing that, for example, if I don't know the name of any student, so I will ask that particular student name. So who has, so it means I am broadcasting, and who will give me that answer, I will assign this MAC address with the IP address to that person. So enough discussion on ARP. You can see more on that, how it works. And now again, remember that what did the data link layer ever do for us? The data link implements communication between any two machines on the local network. You remember that I mentioned you already. It is in your local network, just the your neighborhood computer, which is peer to peer, your next computer which is attached in the system. Okay. And it is uses the source and destination MAC address to address each device, because with each device they move on, they know the MAC address of their immediate computer, and then that's how they travel the information from one source to another. So for example, this PC is connected with the switch there, and then from here to here, so at every single level it has their linkage available. So router is also on the network, therefore it can also communicate with any device on the local network as well. So router has the capability to communicate any single system on the network. So it means that we are able to send our data on our local network once it is connected on the local network, and that's problem how to see. Next problem to solve to communicate with the remote machine. Now that's another thing. So we are now able to understand how our network works in a local network. We are clear about that. Now the next question comes, okay, how I am possible to send a message over a global network or a network which is not part of my local network. Now we are moving to the next stage. Okay. So up till now, again to revise, what are the layers we have done, or what are the, first tell me what are the networking model layers, what are those?
Application layer,
Application,
transfer,
application, from this side I need answer. Application, transport, no, after transport, network, okay, and then data link, and then physical, 5 layers. Okay, so we are already done with the application, then we have done data link. Today we are going to see network. Okay, so the solution is to send the packet to the local router and let it handle the remote delivery of network traffic. So this is the function of router. So there is one more thing today, you are sure that now what is the one more function of router? write it down, this thing, that's important. So what we have learned from the till previous lecture is the main job of data link layer is to communicate over a local area network. But now the question is, as soon as we discussed like how I can remotely connect with any computer which is not my network, then it's mean that whatsoever the information coming from these PCs, everything comes to the router, then it's the router's job to handle that everything for us. So that's what we are saying, that whatsoever the packets are coming here, send the packet to the local router and let it handle to the remote delivery of network traffic. So whatsoever the traffic we have on our own local system, it's the job of a local that router to pass it on, including every single machine on our local network. Clear? So that's a very basic understanding of router. Okay, now the next question comes. How do we decide when to send to the router? How do we decide when to send to the router? So you can see that, again remember it, we will see one more important thing today about your assignment, network assignment. Some of the concepts which we'll cover today will be also applicable to your assignment as well. So you need to be clear about those concepts when you are doing that assignment. So what we are looking is, like with this local area network, they have their network ID. What is network ID? We'll shortly have a look on detail into that, but right now just understand that they have their some ID from where we actually figure it out. Okay, this is this network. And then as we know that it has an interface here which is connected with the NIC card, and then there is the other NIC which is connected on this point and then going to the other network. Okay, so each network on the internet has a network ID. Each time your computer is about to send a network packet, first it will see if it is for the same network ID. Yes, it will just communicate there. If it is not from the same network ID, then it is going to the next level to send to the router. So in that way it start making communication. Let's see if the source and destination are on the same network, which I mentioned, send directly to the destination MAC address. Because remember that in our local network, we already know about who has that IP address with MAC address. So if that IP address is similar, so then system knows that, okay, this IP address belongs to this MAC address, send to this guy. And we are able to send that packet in the local network. Whereas if the destination and source networks are different, now here it comes, like whenever, because again remember that our all communication is done in the form of IP addresses, and IP addresses are on the back end are what? IP addresses, what we have discussed, binary system, and from decimal we always convert into binary numbers, zeros and ones. So if it is on the same network mean maybe we are talking about it is in the same suburb. Then we in the same suburb, we know that it is in this local suburb of, let's say, Hurstville. So if it is in the Hurstville, so we are not going to jump on the next level. But if it is out of the Hurstville, then I'm not going to search that thing in that my local network. Similarly, you're looking a file in your computer. So number of folders, subfolders are there. If you know that in one of the subfolder your that with name is not there, then you have to jump to another folder to see that thing. So whenever your network ID is different, your destination and source, straight away it means that it is for remote transmission. It is for remote transmission. But how this is done, that's now we need to see. You can see now that with every single point when we are moving on, always there is a question on it. Okay, so for every study it's very important for you people as well, like when you are learning, when you reach on one stage and when you move to next stage, always there is a question. That question actually gives you the idea that okay, now what next, how this thing will be resolved, how this thing will be resolved. So as a good student, it's very important that half of the knowledge is asking the right question. That only comes when you are on a right track. Okay, that's for you as a student as well, very important. When you are learning, you should learn in a way that when you ask question, it depicts that you know how things are moving on and how to answer that question. So you can see that at every single stage we are looking different type of questions. So how this is done, what we are talking about, looking the local MAC address with the IP address, but now you are going to communicate over a different network ID. If it is the same one, no problem, but now it is has a different one. So how it can be done to shift that thing on the next network? So it means that that's the job of a network layer. So here now comes a new character of the film, which is known as the network layer. That's his job to do that thing. Again, from my own past experience with the students, once you finish the course, if I ask you about different layers, if your concepts are not clear, for you every answer is same for every layer then. Oh, you got my point? Because your concepts if are not clear in that, because they are so slightly different between their roles. Their roles are very similar. Okay, so that's why it's important for every single role you are clear that what their job is. If you know their job, then you 100% understand, okay, this is how every layer play its part. Make sense? So please, that should be very much clear in your mind. What is the role of application layer? What is the role of data link layer? How the internal layer come to play its part? Okay. Now coming to the network layer, we will now going more in detail about network layer, how it works. Again, remember that application, transport, network layer is here, data link and physical. It means that main job of network layer is to link with the or to communicate with the transport layer and with the data link layer. So the job of network layer is to deliver network traffic from one host to another. So if I ask you now, what is the main difference between data link layer and network layer, what would be your answer in one sentence?
Data
Can
link layer works within a total network network layer. So, and network layer works with it goes to like from one router to another router. It forms working through different network IDs.
Okay, yeah. So in simple terms, of course, with the host to host, we need to explain more on that. But up till now, you know that with the data link, it's hop to hop. With network layer, it is host to host. Okay, just write down that thing. That's one of the important point about your network layer. It is on host to host. What is host mean here is, anyone understand that? What is mean by host? Anyone else? Two hosts are those devices to whom we are actually communicating. For example, if I am going to talk to someone by using Skype, so it means that that particular computer I'm connecting to, that is my host. from my side. If I am going to connect to the eBay server, so my computer and that eBay server is host to host. The end machines to whom they are connecting, actually, they are actually talking to each other wherever they are located in the world. Clear? So these are those two machines. Either that relationship would be in the form of we learn about that. What are the relationships? Client server. What else we have learned in host based? Yeah. Cloud one. Peer to peer. Okay, so these are the relationships, but peer to peer is more in the local network. So it means that if I ask you about the question, what what do you think that peer to peer architecture would works better for which layer? So you will say that it is on the data link layer. So you can see that it's a very small questions. If I give you three options: network layer, data link layer, and transport, if your concepts are not clear, you will be easily tricked into that. So that much understanding you should develop over a period of time during this whole session. So these two hosts are often separated by long distances, not on the same network. So that's clear that they are not on the same network. Whenever we are talking about the network layer, it means that they are not on the same network. They are one local and one another network to whom we need to communicate. So what is the network layer is all about? IP addressing, IP addressing and their associated routing. IP addressing and their routing. Like you know the IP address and where to send that IP address. That's the main job of the network layer is. Now coming toward the IP addressing. Okay, can you please read that slide?
Which device on an IP network requires an IP address? There are two types of IP address: IPv4 address, IPv6 address. For now, we will just consider IP4 address. The IP4 address of a machine must immediately identify that machine from all other components.
Yeah. So initially, when internet was more in the initial stage, they started with the IPv4. Okay. In that one, we have 2 power 32 bit. 2 power 32 bit is a very huge number in billions. So it means that it has billion number of IP addresses possible. Whereas IPv6 is much more on a higher level. When we say IPv4 address, how I can say that it is 32 bit? What do you think? Understand my question? When I say 32 bit IP address, what is mean by that? How our IP address is written? In how many parts? How many different parts we write it IP address? Let's say, give me any IP address name. 192. Hmm? Is it okay? Why? One more. Let's say whatsoever it is. So how many parts it has? 4. And every part has how many bits? How many bits? Every part. Bits. I'm not talking about this is in decimal. When I say bits, suddenly your mind should think in the form of binary numbers. Tell me, what is their bits? 4 bits? Why 8? Why not 4? Someone say 4 and then 8. If I say 4 bits, can 4 bits can be possible? No. 8 bits need to address up till 255. So it means that 8 bits here, 8 bits here, 8 bits here, 8 bits here. So how many altogether? 32 bits. So it means that if this whole world is having a one network where we are actually assigning each and every single computer with the unique number with this terminology with the unique number on that. So 2 power 32 number of combinations could be possible, isn't it? Because those 32 bits can be written in 2 power 32 bits unique forms, and it means that this much number of computers can be assigned different IP addresses. Make sense? So we start with the IPv4 addressing. Why 4? In the 4 main chunks we are dividing into it. What about IPv6? How many their numbers are there? Instead of 4, they are having 2 more. Okay? So with the 64 bits, that's actually with the 64. So how many are they are linked to it? Okay, I will come to this one clear. I don't want to confuse both these concepts first. First finish with IPv4, and then when we come to IPv6, I will clear that. So this is clear with the IPv4. Okay. So first we are considering IPv4 addressing. So as I mentioned, so it's a 32-bit long. Okay. You can see that we have 8 bits, 8 bits, 8 bits, 8 bits, altogether 32 bits. Okay. So what we do is 32 bits divided by 8, 4 equal parts, and express each octet as a decimal number between 0 to 255. That's its range. Between that we are going. That's our boundary for 32-bit IP address. So this is one of the example we have IP address 141.132.196.26. So everyone is okay how to convert 141 into binary number? We have already done that. So if someone has still confusion, I would prefer that you should go and see that lecture notes how to convert decimal into binary. Now coming to the next point, how do computers get an IP address? So with the operating system whatsoever we are using, Linux, Windows, Mac, every machine holds a IP address. It can be configured manually or automatically. Both ways it is possible. Manual administration is more about static addressing. Static means which you are actually manually putting it and it is not changing then. You know that this is your IP address and only that IP address is allocated every time when you are in the network. So as a user, we are actually able to put that IP address by ourselves manually. Whereas second part is automatic administration, which is a dynamic addressing. Dynamic mean according to the situation you are giving the numbers. Currently, 99% time when we are entering into network, we are dynamically allocating the IP addresses from the system to us. So DHCP, usually in your where you can see your Wi-Fi network, you right click it, so go to the properties, you can find it out DHCP. That means dynamic host configuration protocol. So it's a dynamically configuring the protocol on it. So that it actually allocates IP setting to the machine.
Give an example of manual static addressing.
Yeah.
Is it used for?
Yeah, for example, in the same, we will see that in the later on, when you, as I right click on these Wi-Fi settings, in that one there is option as well, static IP address. Static mean you can put 192.168, whatsoever the IP address you put it, every time it will assign to that one only to you. So it will be not changed then.
So, for example, if I am coming to this college to the ATM, the ATMC network,
Hmm.
and if I manually put the IP address,
Hmm.
whatever I put,
Yeah.
so every time I come to this college,
Yeah.
I will get that IP
Yes.
address only.
Yeah. It's normally more usable when there is in the universities there is a staff member. They know that these are the staff members. They will give them the static IP addresses. So they know that okay, these are the allocated one to those people only, and from there they know that okay, these are allocated to these people, because every time it's hard to change their IP addresses or to maintain that okay, this IP address belongs to whom, because MAC address every time is hard to match to or to remember for as a human.
So VPN does the dynamic one. VPN.
No, see, VPN is something different. VPN, we are actually sitting over our own network and then jumping into some other world. So first of all, we have to connect with our local network. That we are actually making a tunnel with someone else straight away. That's different. We'll see that one later on when we come to that point when you understand all the basics of networks. So when the machine boots, it sends a broadcast requiring IP settings. The network local DHCP server respond with associated IP address, subnet mask. We'll see this one very important concept, and other settings. So as soon as you are configuring, or for example, when you are putting the password of any network, I think it takes only few seconds to connect to a network first time. That's a moment it is actually doing these all job. The DHCP of that local system, local server, is giving you the IP address, subnet mask, and some other settings. So you can use Wi-Fi network or your local area network. Some of the other important IP settings. So to communicate on an IP network, a machine requires, what are the things we required? IP address, first of all, write it down these things. Second is local router's address. For example, if I want to communicate with any network, of course, if it is my own network, I don't have to care. I'm pretty much sure that this is my network. Then I don't have any problem to locate that. But if I want to communicate with some other server or any other network, what the things I need? IP address and the router's address. But from my own network, when I start from my own computer, I need to know my own IP address, then need to know my server's address, local router's address, which is a default gateway on Windows or a default router on Linux. Because remember that this is your computer, this is your router, and then you are going outside the world. So your IP address, your local router address, for you that matters, because these are the two main, and then you are actually, that's a gateway you are entering into the world. For example, when you are in your home country, from your own country, when you are going from one city to another city, you don't need permissions, you are still in the one country. But as soon as you are going to some other country, you need to pass a gateway of that country, immigration. Once you pass immigration, then you can't come back unless you have to then give that whole process back. So it's like that, like you are going from your own network to another network, and then kind of immigration you are doing it over the global network now. So what the things IP address we need? Router's address, subnet mask. That's the third thing we are going to see this. What is that about later on? Subnet mask and domain name system or server. So it means that in order to establish a connection with any network on a globally between host to host, I need these four things always. Put this thing in your mind. Remember that from today's lecture, that's the crux of that. With on IP network, these are the four things we need to communicate over the global network. What are those? IP address,
Local router.
your local address, because that's the point where you have to go or you can say that that's your local airport, local international airport, where you go to fly. And then what you need?
Subnet mask.
Subnet mask is also kind of a thing which you will understand in few minutes. And then domain name server as well. These two things are new, which we are now. It means that these two things you already know that, and we are going to now see what are those questions. Then again, that's how the question arises in your mind. Now, what is the job of these two things? Okay. The fourth setting, which is not essential but particularly useful in the domain name server IP address. Domain name servers are responsible for converting. Yeah, this is actually, you can say that these are mainly more important, first three. The fourth one is more for used to make it more simple for as a human. For example, if someone says that 142.196.50.2, and if I say that yahoo.com, which one is easy to remember? The first one or second one? Second one, because as a human, we understand alphabets more easily, whereas computer understand numbers more easily. That's a difference between the capabilities. We have the capabilities of alphabets. Computers are the capabilities of numbers. So for us, it's easy to remember names. That's why the main job of domain name is to convert in that IP address into some human interface letters where we understand those one easily. So google.com equivalent to this thing. Hard to remember this, but everyone remember this thing easily. Okay, just give me a minute. Okay, so our now next point, which is very important again, is about network node components of an IP address. So there are two main parts of our IP address. Now actually we are more digging into IP address first. So remember that what from the last slide we have learned? Three main things: IP address, locals router address, and then subnet mask. So therefore, in order to learn those three things, now we are more going inside the IP address. How IP address looks like and what is the difference between their network bits and node bits. Okay. Node, just remember that in a local network, the definition of node is whatsoever your computer is, that is one node. That's another name of saying the computer in the terminology of networking. Let's say if the 10 computers are communicated in a network, we say there are 10 nodes in that. Okay. So IP address consists of two main parts. High order bits specify the IP network of the IP address. Lower order bits specify the network of the node bits. So what is going on here is, remember that network bits are common to all hosts on an IP network, and the node bits specify a particular host on that network. So let's assume that I have 192.168 is my local network ID. So it means that this would be the same for my every computer in that local network. That is a network ID. After this, 1.1, 1.2, 2.1, 2.2 is my node bits, which is inside my that 10 computers, 50 computers, they have their IP addresses.
That is the local network.
Yeah, no, local net itself. Again, this is a similar thing which I explained. This is your city code, this is your suburb code. Remember like that. Your city code, whatsoever the parcel you're sending in Sydney, your city code overall is same, let's say. That changes whenever you just jump to the next city then. Make sense? So node bits are more like your own local computer number of systems which explain about that. We will come to these things with more examples in the coming slides. Subnet mask. What do you think from the world coming out from there with the subnet? From the definition of that word, what do you think? What is that? Subnet means. Hmm? What do you think? Subnet definition. Anyone? I'm not looking to the definition of the networking. I'm just asking the normal dictionary definition of subnetting. If I have a net, subnet. If I have a folder, subfolder. Means
A small part of the
when we have a one folder, we make it. If we make 10 different folders in that,
subfolders.
we are making
Subfolders.
subfolders. Okay? Can just sit there. Okay, and close the door. Close the door. So, subfolder. Is it clear? So remember that if I purchased a computer and in that computer they have a limitation that you can make in your computer 2 power 32 number of folders only, means it's in some number in billions, come 4 billions or something like that. So it means that number of folders I can make it in that computer. After that I need to purchase a new computer to make that number of folders. So the point comes is if those folders are already consumed or used, then I have shortage of folders. So rather I'm going to buy a new computer, why not with that every folder I can make a subfolder in that. So in that way computer still understand that, oh, these are only 2 power 32, but we are actually making subdivision of that. Okay? So similarly our that whole world's network is working. It has eventually started from 2 power 32 bits. So we have this much number of unique IP addresses. But by having subnetting, we can actually make it more and more. We can make billion trillions of that, because in every single that folder we can make again 2 power 32 as number of IP addresses as well. Okay? Is it clear? So that's why the concept of subnetting comes. So what the subnetting is doing? A subnetting mask applies to all machines host on an IP network. The format of a subnet mask is a series of binary 1 bits. Again, I remember that I told you that on the extreme left side, they are the network bits. They are the network bits from where actually that network is assigned, and we know that what is a network is. And the extreme right ones are for the that node or that computer or that local computer's address. Hence, a subnet mask tells us how many bits of an IP address is devoted to the network portion and how many are denoted to the node portion. In general, the following notation is used to identify a machine in a network with the, you write the IP address and then write the subnet mask. Now that subnet mask is quite a relative number. You can come forward here. Come forward here. It's a quite a relative number. What does it mean by that? It's mean by that is, for example, if in ATMC in one semester we have a class of 100 students, so how many number of IP addresses I need? 100 IP addresses I need to connect those all computers or nodes. Okay, so it means that if I need those 100 computers to connect with those IP addresses, how I can assign the IP addresses? What are my ranges of IP addresses I can assign to the network? But 2 power 32 is too big number. I need only 100. Why I should go up to that? I'm wasting my resources. Tell me. So how many number of 2 power what I need the numbers, which is enough for my local network? 2 power 7 is what? 1 128. And what about 2 power 6? 64. It means that with the 2 power 6 I'm not able to use all those numbers, so I need 2 power 7 minimum. Okay, so I need 2 power 7, which is 128 number of computers I can assign with the, so it means that 2 power 7 bits, it means that only my 7 of this subnet mask is enough for me to manage my whole network. I don't need more than that. Okay, at this moment I know that you understand the concept only 20%, but you just need to realize that we are coming to that point eventually where you understand all those points. But here most important point is subnet mask is all about when we are making any local network, it depends on our usage. Let's say if I need only 10 computers, how many unique IP addresses I need, bits I need? 2 power 2 power 4, because 2 power 3 is 8. So it means that they are not enough to cover my all IP addresses or my local numbers. So it means that out of those 32 bits of my IP address, those 32 bits, I am using only how many? If 10 computers are there, 2 power 4. So it means that up till here we have no, this is 8, this is 8, this is 8. Out of that 4, I am using this 4 only. These 4 different bits starting from 000 to 111 are enough for me to assign 16 different computers. But I need 10. It's okay. Some extras are there. That's fine. Is it clear? We'll see some examples now. Now, looking toward how to find out the network address, how to see the network address of an IP address. So there are two different ways. If we replace all node bits of an IP address with zeros, we get the IP address subnet network address. What is that? We'll see. And or otherwise, we have another option. If we do a bitwise AND, you know the AND gate or gate, we use the AND of the IP address with the subnet. We also get the IP address network address as well. So there are two different ways to do that. Let's see. So this is one example. Please write down this example, everyone. Take the notebook out because this is part of your assignment. If you understand this, this will give you the understanding how your assignment would be then. It's based on that. So let's assume that you have a local PC address which has IP address of 124.182.42.3 slash, and this is how you are writing the subnet mask. Usually when you're doing a job as a network administrator or those things, they assign you or they tell you something about like this way, and you as a network engineer know that okay, this is mean by this 255.255.255.128. Now this is your subnet mask, this is your IP address of the one computer, any XYZ computer. By looking to this subnet mask, what do you think, how many different IP addresses I can assign to that network? What do you think? Tell me. By looking to this subnet mask, how many different IP addresses I can assign to the network? Hmm? 2 power 8 is how much? How you know that it's 256?
128 is power 7, then it's double.
Why you are making double?
Like into 2,
Hmm?
128 into 2. And then we do to the power and become 1 plus 1.
Okay, just wait. Okay, let's see first of all IP address. Okay, first of all, what we are doing is by looking the IP address and the subnet mask, we are trying to find it out what is the network portion and what is the node portion. Okay. Again, want to recap. In this example right now, we are looking two things. One thing is about to find it out what is my network address and what is my node address. So by doing this example, we are sure that we can find it out that. So we need these two things to do that. So this is your IP address. IP address in binary conversion is like this. Clear? And this is your subnet mask address. Okay? Subnet mask address. Before moving forward, just from the subnet mask, when you are writing in the binary form, these all ones are already consumed. How many number of zeros are there? 7. 2 power 7. 2 power 7 is how much? So it means I have 128 number of computers can be adjusted in this network. Isn't it? Because all other ones are already used. So again, coming back, I'm actually moving with two different concepts at the same time, but at the end we will understand that. So right now we are looking how to differentiate the node portion and network portion, which is first of all write down your IP address in binary form, subnet mask in binary form. Done. Once you write down, what we can do is we can use the AND operation. What is AND operation is? 0 1 is 0, 1 1 is 1. Again, whenever it's 1 1, it's 1, or 0 0, it's 0. But when it's 0 1, it's 0. Remember that for the AND gate. Please do by yourself this example, how to use a AND gate, and can you get this answer? When you use a AND gate, are you getting the answer this one? Because do you remember about AND gate? 0 0, 0 0 is 0, 0 1, 1 0, 1 0 0, because and means like when both things are correct at the same time, then it's give you an answer. And 1 1 is 1. It's a similar AND gate is something like that. If I ask you when you come to the next class, please bring your notebook and pen. When I'm using AND, it means that any of the thing is missing, you are not allowed. So both should be correct to make it 1. But if I say that if you bring pen or a pencil, then mean either you have a pen or a pencil, you are allowed to enter. So it means still 1 0, any one of the answer ones comes once, that's OR gate. With the AND, when both conditions true, then it's 1, otherwise it's 0. So once we do that, what's the answer we are getting? We AND it, this is the answer we are getting. You can see that 124, this remains same, 182, 42 remain the same, because they all have 1 1 1 1 on the subnet mask. Okay, by doing this, what we are achieving at the end, we are actually finding out our network address. It means that by using my own computer, the IP address, I can easily find out the network address of my computer as well. Why we are doing it? Anyone can tell me why we are interested in network address?
So that
What was the main aim initially when we start the lecture today?
from one network to communicate from one network to another network, we need the network.
Yeah, so what are the 3 things we have discussed? IP address, local router's IP address. So local that's what we are doing, local IP. So we are reaching to the local IP address by using this, because this is a network address of my that local network. Okay, so this, it means that this is my network ID, network portion 124.182.42.0. This is my network ID of my local computer. So it means that in that network, whatsoever the computer it has, when you end with the subnet mask, it will give you the same answer. Let's say you have an IP address of 142.182.42.3. I have 4, someone else has 5, 6. Whenever you do the AND gate like this, because your subnet mask is this one, it will always give you 0 there.
Sir,
Yes.
when you said that there are for the when we discuss the subnet mask,
Mhm.
in 128, there are only 7 more places to accommodate other computers. So is this applicable for every other zero, for IP address and in the network address as well?
So what is the last point you said? Is it?
Applicable for all the zeros. I mean, the last zero in the network address. Does it mean that there can be 8
Oh.
other networks that can be connected?
No, 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 not 8 networks. Again, remember that one more thing. Your subnet mask is actually a number which is defined by our requirement. In my network, it depends how many number of computers I need. I will define my subnet mask. So I'm just talking about my local area network, where I'm actually giving the IP addresses of how many number of 128 number of computers are possible to be used in that network, in my local area network. Okay, and let's say, as I mentioned before, if I need the 1,000 computers to work in my local area network, how many number of I need? Tell me. If I need 1,000 computers, how many power of bits I need? 2 power 10 is how much? Okay, next time I need the answer from someone else, not from you. Okay, you are giving the answer only. Okay, what about if I need 2,000? If I need 2,000 computers, how many number of IP addresses I need? Two. If I need 2,000 computers to connect in a network where 2,000, so it depends on actually an organization. If one organization is bigger, they need computers for 2,000 people. So how many number of IP number of bits? Tell me. 2 power? What is 2 power 11 is? How much? 2048. So it's 2 power 11 is 11 bits. So I will go there, my subnet mask, I will make it this one 0, 8, this 0, this 0, this 0. This is my subnet mask now. Make sense?
So
So now by making it these 11 zeros, I'm able to make how many number of IP addresses? 2048 computers. Make sense? Because with having those 11 bits, what are the different ways those 11 bits can be written? 2 power 11. That's a normal mathematics formula. It means I can get 2048 unique IP addresses. Okay, and based on that, my network ID would be changed as well. Based on that, my network ID will be changed as well. But I'm not going in that detail. That I already mentioned you how to find the network ID. Do the subnetting mask with this one and this one. You will get that answers. But right now, I'm not going into that detail. But you can do that. Let's say now, if you do, let's try this one with the last 3 bits. If we change that, what is the answer then? So it would be
0, 0, 0. That also is a 0. That's 0 again. That's
so. Then what is the answer of this? Convert it into say in the binary form. 2, 4, 8. Still 42, is it? Still 42. Still it means, is it clear? So still on this network ID is enough for me. You can see that 32 plus 8 is 40. 40 plus 2 is 42. Still it's 42 is, it means that that's my, still my network ID would be still 124.182.42. With same network ID, I can manage this number of computers. So this is your network portion. You can see that. Can you check it again? It's still 42. I'm confused. Huh? Anyone check this? 2, 1, 2.0. Hmm? It's 1, 2. Oh, this is a 0, 1. Yes, this is a 0. Yes. This is not 1. This is 0. So it's 40. That's why I was thinking why it's like we change the bit, still it is why 42. So this was 0. With this 0, now our with making it 11 number of bits, our network ID is now 124.182.40. Okay, let's do one more example here by looking into the same. I need now for Tasmania, I need 10,000 computers in a network for the whole Tasmania. Tell me how many number of bits I need. So we'll make everything right now. Have a look. Tell me, for 10,000 computers in whole Tasmania, how many number of bits I need? Okay, so we were looking to the example of, okay, please keep quiet. For Tasmania, so 10,000 computers we need. So we have seen that 2 power 14 is 16384, 16,384. If we make it 2 power 13, it is less than 10,000. So it means that definitely these 14 bits, we need to spare 14 bits. How many bits need to spare? 14 bits. So what we'll do, 8 are already here, 10, 11, 12,
8, then 9, 10.
8, 9, 10, 11, 12, 13, 14. So 2 power 14, 16,384. So it means that, so these are all zeros, we need to make it. Now we are able to connect 10,000 computers in this network. Okay. So what is the network ID now? By doing this, what would be the network ID? Because this is all become zero now. So this becomes zero as well. So our network ID would be now for Tasmania is 124.182.0.0. Clear? And this portion now going back to the original example, which we are looking toward our own one. So by looking to that example, we can actually, this is our network portion, this is node portion, this is node portion, and this is our network portion. So in that way we can see that thing. Okay, is it clear about network portion and node portion clear now? Any questions? Okay, now I already discussed that, but let's see how you understand from there. I'm just putting in front of you without saying anything. Let's say how you understand this slide. I'm giving you 30 seconds. Let's see what you understand from that. We'll do later. Yes. Okay, raise your hand to answer. Anyone? First, raise your hand if you understand the concept. Hmm? Yes, same example we are carry forward on. 1 to 2 power 7, 128 bits. 7 zeros are free, which we are going to use, which are 7 zeros. 7 bits are free, which we can use. So it means that in that whole network, my IP addresses can start from here, keep moving up till 127, because 0 to 127 is how many total? 128 bits. And for every single one, conversion of this one is this one is this is same. So you can see that this is a network ID. That's why we say this is a network portion. This is not changing. Only that node portion is changing. Node portion is what? Your personal computer IP address. Your connected devices, your own IP address. Clear? Now, next thing comes. So there are, it means total number of 128 hosts are possible in that network, but 2 of them are for something for reserved purposes. So it means that every time whatsoever the number of bits you need, it is 2 power n minus 2. That's a formula. Means if I need, let's say, 127 computers, so how many number of bits I can use? If I need a network of 127 computers, how many? How many number of bits I need to free? Hmm? 2 power 7 or 8? See, 2 power 7 is 128. I need 2 extra computers free. So it means that I have to then jump to 2 power 8. So that's a very small part of that thing. So whatsoever your number is, always minus 2. So 2 are for the reserve purposes. We'll see what is that about later on. But right now, total number of usable hosts are total number of free empty bits minus 2. So is it clear about now subnet mask? I think, and that's now when you see your that network assignment again, and I'll also send you that recording of my one of the explanation on that. Now it makes more sense to you. So I would now assume that from this week, when you are going to the lab, also till the next week, you should finish at least, maybe next week is the holidays, is it? Or not yet?
One more day. 23rd.
Today is 12 plus 7, 19. 19 is the working day, I think. Yes, after that. So I would prefer that by next week, you should finish at least 50% of your assignment, 50 to 60%. Everyone should come independently or privately to discuss with me about your assignment, what you understand, where you reach, so you know how this thing works. That assignment is not only about getting marks. That assignment is like the same way you are going to design a network, how you're going to do that. So that's a hands-on experience of that skill. If you know that, that gives you the confidence how to make a network. Make sense? So please, and that is 15%. I know that if you finish 50% of your job by next week, then 99% I'm sure in holidays you are not going to do anything on your assignment. And then you will come after 2 weeks, your time is already very at the end, and you have so many other assignments, everything is approaching as well, and it would be hard for you to do that. So in your network assignment, you need to see the requirements. What are the requirements given there? So those requirements are all about that subnetting and those things. Okay, come to the next concept now, which is about CIDR. That's last part of our today's session. So that is classless inter-domain routing. That's actually the same thing what we have learned, but another way of writing the things. In the last example, we were actually writing the subnet mask in full, isn't it? In that one, just there is a small change in that. Rather writing the number of free bits, we are writing here the number of ones bit,
The used one.
used ones. Let's say total number of bits are how many? 32.
25 are occupied.
So 7 are occupied already. So we write 25. So whenever, this is another way of writing the thing.
If 7 are occupied, then 7 are ones. We should get 7.
No. Sevens are the zeros, because zeros means those are empty ones. Ones are already used one. So here they are saying that these are 25 bits slash 25 bits, telling that they are network bits. They are network bits. So the CIDR method of writing the thing is, whatever your IP address slash 25 mean, that's your network bits. Network bits are already consumed by 11111. It's mean 25 means 25 ones, and the rest are the zeros ones. So this is another way of looking the same thing, the problem in the other way. For example, one thing you're looking from this way, and other is from this way. So you can subtract it and you get the answers. So you can see that this thing and this thing is the same thing. This is just another way of writing the thing in the field of networking. If someone casually say to you that, oh, I need to design a network, we need 22 network bits. So you can easily assume that 22 are the ones and the rest 10 are the zeros. 10 zeros mean those 2 power 10 are the number of bits freely available which I can use to assign the network, assign the computers. Okay. So you can see that 25 ones. This is how it makes 25 ones. Please check it again if you have any question. All clear? Permanently clear. Huh? Please always try to make a habit of writing, because in that way you remember the things what you have done. Otherwise, after half an hour, if will ask you, half of you will be empty. You'll say, "Oh yeah, I have learned that this is something. Yeah, yeah, that's all." That's what you understand at the end of the day. Then, but if you just write maybe a one-page document, only very few points, then you know that okay, how you symmetrically move from very first point to the end point, and then straight away you recall every single thing. Then it helps you in your final exams. And of course, in the future, when you're going for interviews, open your that notebook, remind you everything like the film, what you have done at that time. Otherwise, you can go on YouTube and learn this thing as well, believe me. So try to understand that when you're sitting in the lecture, that's a difference between face-to-face learning and just learning by yourself over a computer. So how this all helps? Your computer wants to communicate with another machine. It knows its own IP address and that of the destination. It can determine with the help of the subnet mask the network address of the source and the destination. So it means that with every IP address, we are able to know our network address as well. So if they are equal, they are local communication. If they are not equal, it's a remote communication. That's how simple it is. Like how by having that IP address with the subnet mask, our system knows that whatsoever the communication is going on is on my own network or on my other network, which is going remotely from my computer to my router and then going on the network. Yeah. So always see subnet mask again. Remember that subnet mask is always defined when we are going to design any new network. Anytime when anyone asks you, okay, I need to make a network of computer, you first question should be how many number of PCs you need to put it in that. They will say, oh, I need only 20 computers. Straight away you can see, okay, 2 power 5, 32 computers. It's mean I need 5 bits empty to make my subnet mask. And that subnet mask actually then start your journey toward understanding the network bits, node bits, and every single part of that. Okay. And then this is how you know that this is your local network or your remote network. So in that way, our system knows that where to send the packets, to my local network or to my router. So router is able to take all those inquiries of those computers who are in the local network, take it on the router, and router's job is to send over the global network. So with the type of IP addresses, this is an important thing which is part of your assignment, because this is classified internationally. They have assigned that okay, these are the IP addresses used for this particular purpose. So you can go to this link where you can see that some are the reserved IP addresses which we can't use them. Some of them which we are able to use them. So based on that, in your assignment, you are going to use those particular IP addresses only. So the public one are only used to communicate over the internet. Private IP addresses are discarded by routers if the IP address is private, because that's how IEEE organization is actually looking toward assigning of IP addresses. They made some publics, make some private, and in that way they know that if they make it any public one private or private and public, the routers never accept that. Routers have that information already in their system. So these are the private ranges. Okay, these are in the private ranges, which is only applicable in inside the networks. So these are all private. You can never see any IP address 192.168. something for Google or some public domain. They are used for local one inside the network, private. Okay, they are for the private. Private means inside in the local networks. So when it comes outside, it never be 192.168.
When we make a local network, then that is a local network is basically private IP address.
Yes, because they are not seen by the world. The global ones are those which are the public one. These can be seen by anyone. For example, Google has their IP address that could not be having private one. If it is private, then it is not accessible. So this on this website link you can see reserved IP addresses plus the private one which you are not able to use them as a public. And also those public would be as soon as when your network is moving on the network of a routers, then it become public. But when it's inside, it's private.
Like in a house,
Yeah.
that network is already
For example, every house in the whole world, 89-90% time, every house usually what are the IP addresses we have? 192.168.0.1. Everyone has. Why? Because the outer network is different. So inside we are all same again. So this is how we make it simple. Because that's a private one in my home, and everyone with the home same thing could be possible. But outside is different, and by having that, we are able to figure it out where this IP address is located. So the computer on most home networks use private IP addresses. See, this is what I'm explaining, which is actually assigned by the DHCP server. Host network routers use NAT, network address translation, to provide internet access to these hosts. This is achieved by changing the IP address of request to that of the IP address on the ISP side of the router. IP ports are used by the NAT router to distinguish the traffic from different hosts on the home network. So, one more thing, what the NAT is doing? Network address translation. For example, in a home network, we have 10 different devices connecting to our router, local router, and that Wi-Fi device. So every one data is going to that router. So that's the job of because with the local one, that is in the form of private IP addresses. But as soon as you're jumping toward the global one, what the home network routers are using? They are using a NAT to provide internet access to these hosts. So in that one, this is something else coming on to play its part to give you some type of public IP address so that you can work it on that. So this is achieved by changing IP address of request to that of the IP address on the ISP side. So in that way, it is going to change the IP addresses. As soon as it is moving on the international domain in the router side, going to the ISP. Yeah, let's say for example, from my router, it's going to the Telstra or Optus. So that's the job of the Optus to change the IP address of that request to the public one, because as soon as it's going into the public one, it doesn't know that what is that. It only knows the public IP address, not the private IP addresses. So in that way, it is able to distinguish the traffic from different hosts on the home network. We'll see this one more in detail in topic 6. So this is a question for the next week now, which is making sense what they look like. So the role of routers, the path between your computer and a distance web or other server could be maybe a router's hop away. For example, going to Google, you are actually passing 13 different routers. So the role of router is to move a network packet forward one step toward its destination. So taking your packet on a router base to the next router to the next router, and let's say you are going to access the Google, which is a public IP address, and you need maybe 13 different routers to pass on. Quickly have a look this example. Let's say this example is explaining that what is the job of a router. Let's say if you are going from Sydney to Melbourne. So if you're going from Sydney to Melbourne, this, understand that this is kind of a sign which is telling you that where to move. So this is the job of a router. Like the same way, if I'm going to Sydney to Melbourne, so I have to see what are the different options I have. First I have to go toward this point, and then it is moving toward this point, and then it is staying to the Melbourne. So different routers actually help you to pass your packet toward the right destination. That's the job of that. They show you the way. For example, again, when we are going on motorways, or we always see like bigger sign comes to going to Canberra or going to Melbourne. So we know that now that's the point of that router is. That sign is actually a router is telling them that okay, you need to go there or there. So this router analogy of this example is giving you the same thing, how these things works. Okay, now this is another important slide. We are just at the end. How many slides left? Let me see. Yeah, still there are few. Okay. So see this one now, what it is doing here. How do routers decide which route to use? So again, I mentioned you, for router it has minimum how many number of IP addresses? 2. One inner side, one outer side. Is it clear? Remember that last time I told you, like for the router, they have always minimum 2 IP addresses assigned. One on the local network, one on the this next network. So this network has the ID of this one. This is the network ID. Okay. So one of the interface starting, we the first bit we are giving to that interface to the local router. So what we are doing is, let's say our destination is where 141.132.128.0/24. 128.0. So where is that? This one. Our destination is this one. What is this interface? Their interface is this one. Okay. So it's for example, so remember that for a destination network, when we are looking toward with respect to this, let's say I'm coming from here. So 141.132.128.1. So my first hop would be here on this network, and then there on the destination for this one. Let's say my destination is now on 32.0. Where is 32.0? This one on this network ID. So I'm again coming from which point? From this interface, and then because this is the next hop, so they are both same in that case. Then 96.0 is this one. This is my destination, so I'm coming from where? I'm coming from 32.1, 32.4, from this to this, and then here. And the last one 64.0. So again I'm coming from 132 dot interface. What is the interface coming from? There is interface is this one, which is going to 32.1. Yeah, with respect to that, again remember that I'm looking with respect to this interface with all the examples, with this interface looking with respect to this, with respect to this, and this is how their IP addresses are moving on. Okay. So again, remember that with every router's inner interface, 128.1 is this one. That's why we have some reserved ones. And 128.0 is the network ID. This has their own network ID. This has their own network ID. This has their own. So there are how many different networks are there? 4. 1, 2, 3, 4 networks are there. And these are there. Let's say if I'm going from here to here, my first hop would be there and then there. And in a similar way, from here again, moving to the next hop, we are moving towards their destinations. So there are more examples or things are possible as well. You can make as many as number of examples there. So the router, what if the network configuration changes? So router communicates with one another to ensure all routers know about network changes. For example, if a router is offline, a particular route is overloaded or new routes added or removed. It's similar thing like that. The road networks of Australia, if there is something, some road work is going on, they keep telling to the other one, tell other people to change their path, don't come there because the work is going on. So similar, sorry, yeah, minimize the congestion. So no more people come to the same point. So basically, routers of different networks have their route. So it means that we can say that it's a network of routers as well at the same time. Networks of routers as well, which are talking with each other. So the common routing protocol which actually work, there are OSPF, RIP, BGP, which is broader gateway protocols. So these are all different protocols which work on the router level, and we will see this one later on. And these things are always in the tables updated as well. And you can see this is how the IPv4 header look like. In the information in the source IP header provide information to routers and the destination host about the network packet. So important information includes source address, destination address with the header size of 20 to 60 bytes and TTL, header checksum. So these all things are part of your network. So this is a total format of your IPv4 header, which has source address, destination address, protocol, their identification flag. So all have different jobs to do that. I'm not going in that detail, but this is your on. Remember that we are on layer number starting from application, transport, then network. So network, these all things are added into the system. Remember the last time Ethernet frame. So this is your IPv4 header format, how it looks like. Yeah, so yeah, there is some more examples when you do in the lab today, which is about how the thing works. You'll see these are related to that. So there are some basics of TTL and how they work are also given there. Other important thing is about naming of internet hosts. Companies and organizations require a block of public IP addresses. So you can see that from here, always they are assigned to some IP addresses, assigned IP addresses to the network. Public one, public are always someone are there. So the block of addresses are associated with the organization, domain name. For example, Google always reserves some IP addresses. eBay, Yahoo, every company, public one, always assign IP addresses. Similarly, Federation has their IP addresses. The public one are used as a purchased those ones, and they are assigned to them. They can't be changed. And actually, this is the authority who are looking toward to assign those things. I'm not going into that detail. It's more like a descriptive thing, which actually tells you that what are the IP addresses assigned to which number of different people geographically as well. Okay, we'll see this two slides in the next or maybe in the lab part. Then we're already running out of time. Okay, let me finish. We have 2 minutes. Okay, for domain name system, name resolution, as I mentioned in the start, Four things: internet, IP address. What was four things? IP address, subnet mask, router's address, and the fourth was a domain name system. Where a domain name system job is to convert that IP number into our name. I already explained you about that. So for example, apple.com have a name in the IP address form as well. So their main job is to resolve the names handled by your local DNS, that of your DNS server. So there is a server. Their main job is to just do that job. Take the IP address, put it in the, give it the name, and that name is permanent. So in that way, for us, we know that, because for Google, when we search it on, it's not like that Google has only one server. When we search it, everyone's information is going to that same server. Maybe with the google.com, they have 50 or 100 different IP addresses they have reserved. Okay, and that's why you see that sometime when you see any matches live on some Netflix or any channel, maybe you are opening two different computers, opening the same thing. One is coming with some delay and one is coming perfectly. Maybe they are connected to two different servers. They are with the same network, but because, let's say, Zoom, when the time of corona comes, they need more servers. Why? Because more people are using them. So if they have less number of servers, so it means that people can't be connected. So when you increase the number of servers, automatically your first on the top, the name label is same, but number of IP addresses can be dependent on how many usage you have, because you have to pay for that. And then IPv6. IPv6 is the recent version of the IP protocol. It is developed by again IETF to deal with IPv4 address exhaustion, because IPv4 addresses are now going to finish. That's why they make it now IPv6, which is 128 bits. With 2 power 128, it is a very huge number, which is addresses for every observable star in the universe. So this much numbers we are able to now use it, which is very, very higher number. So that's why IPv6 version comes. Because you know that initially we have only 32-bit computers. Now we have 64-bit computers. That's another reason as well. So for IPv6, they have 128 bits. Remember that. IPv6, they have 128 bits. And in this one, this is how we write the IPv6 versions. 1, 2, 3, 4, 5, 6, 7, 8. So 128 divided by 8. So that's how we divided the 128 bits into 8 equal parts. Okay. So it's a 8 lots of 4 again, which is used in the IPv6. Yeah, today you're going to see a lot of things about Linux command line in your lab, Wireshark, these different capturing of packets in today's lab. And that's all for today then. Thank you very much. To finish, yeah, we're already running late.